Hello everyone, welcome back to the channel. Today we are going to discuss another very good concept in this video. So we are given a question, right? So we have to find, we are given a string and we have to return the size of the longest substring, right? Which has each vowel even number of times, right? Each vowel is even number of times. Okay, right? So A, E, I, O, U are our vowel, and we have to find that a substring. We have to find a substring, right? So this is my string, and this is my substring. I have to find a substring which has the occurrence of every vowel even number of times. Got it? Right. So let me take a simple example. Right. So here, what would be our maximum length? Right. What would be our maximum length? So KII is definitely going to be our answer, right? Because the value of all the vowels are even, so value of I is even, right? All the vowels are even. If we take the entire string, so value of E is odd, so I cannot pick this up. Okay, I cannot pick this up, right? So this is definitely going to be my answer, I guess. Right. If we pick this, so again, I cannot pick this prefix. I cannot pick prefix, right? This is my prefix of the substring, right? So I cannot pick this prefix because it is having odd number of O, correct? This is having odd number of E, sorry. So this is K double I is my answer, right? So here my answer would be 3. So this is what the question is trying to say. You have to find the length of a substring which is having even number of vowels. So what kind of intuition do you have? What kind of, so for the brute force would be uh, just simply iterate and generate all the n square substrings. Have to generate all the n square substrings. So they would and check whether the occurrence of all the vowels are even or not, right? So this would give me the TLE, right? Because as you can see, the constraints are, I guess, in the power of 5, 10 to the power 5, right? See, the constraints are 10 to the power 5, right? So we cannot apply this algorithm, right? So brute force is not very, very great solution, right? So can we think of something, an algorithm as a sliding window? Why sliding window? Uh, can we apply that? Can we apply that? I'm thinking that, see, as in when you hear this term, longest substring, and counts, right? So this algorithm should always come to your mind because what we do in sliding window, we expand and we shrink, right? This is what we do in sliding window. Correct. On some conditions, right? Definitely. So here, if we apply sliding window, see my left pointer is here initially, and if you try to expand, expand, right? And if we pick this E, if I'm going to have this E in my window, that is definitely going to cause me my problem because at this point I am going to shrink my window. As in when I occur, this E occurs, or let us say this O occurs, right? So this O are matched, but now I am trying to remove this E. I'm trying to find another E, but what does in sliding window we do? We try to shrink this window. So I am shrinking my window. So this is my window now, right? Now I am increasing my window to OK, right? Then again, I am finding another. See, if I get my OK, so now I will be again shrinking my window because initially my occurrences of O, occurrences over O were even, right? And occurrences of E were odd, right? So in order to find another E, we made this as even, right? We shrink our window here, right? So here occurrences of E is even, but the occurrence of O become odd, right. But there may be a case that we find another E here. So this entire string would be our answer here. But what we did in sliding window, we contracted this window. Why we contracted? Because we know that this cannot be our answer. So that's why we contracted. But in future, this may contribute to our answer. Right. But at this instant, we found that this cannot be our answer. At this instant, we found that this E cannot be our answer. Right. Correct. So this is how I guess sliding window we cannot apply because at the particular point, what we are trying to do is we are making this O. O is currently even, right? O is currently okay. This is not okay. But in order to make this okay, I am making this as false. I am making this occurrence. I am destroying this O, right? I am destroying this O and E. I am destroying this prefix. I am destroying this window, and I'm making this as my window. And right, this part can be my window. right? So sliding window cannot work. This we have proved using this example. So what can we do now? We have to maintain individual counters, that individual occurrences for all the vowels, right? So that is definitely A, E, I, O, U. So that is definitely the case. I have to maintain the occurrences, right? So now, if we take O, right? So initially, all the occurrences are zero. Initially, this is my data structure, right? This is any data structure you can think of. I don't know now, for now, that what data structure this is, right? So this is a data structure, right? So initially, at this point, the index -1, this is the state, right? And what does this zero represent? This zero represent that the occurrence of A is even. The occurrence of E is also even, right? So this is what it represents. So let us say here if it is 1, so the occurrence of A is odd. See, pay attention. The occurrence of E is odd. E is odd. I'm not saying the count of. I'm not maintaining the count. I'm maintaining the Boolean values, or you can say the bit values, right? Either it is 0. There are two states here. Either it is 0 or either it is 1. 0 represent it is even, 1 represent it is odd. Right? I'm not maintaining the frequency, I'm maintaining the states, right? Because this is what I want. This I don't care about the occurrences. I care about the parity. I care about the parity, right? So initially all the parity is 0. Right. Correct. I hope I'm clear. Now if I move my pointer here, now, what will be the parity of O? So it would be changed from 0 to 1. It is going to change from 0 to 1. Correct. So can you represent this in terms of integer? Right. Let us say I'm an integer t. Right. Integer t is what is 0, 1. Initially it is 0. Correct. Initially it is 0. Now I got one O. So let us say this is A, E, I, O, U. So this is a kind of bit representation of T, of in any integer T, right? So initially the T is 0, right? So the bit representation, it is this, like this, right? So each and every position represents the vowel, right? I have represent each and every bit position as vowel. Correct. Now I'm thinking in terms of bit manipulation, right? I've shifted my mindset from sliding window to bit manipulation, right? Bit manipulation, because see, this is very bit manipulation, or you can say bit mask. I have created a mask here. Why I have created, I will explain you later, because I have to maintain the count of each and every vowels, right? Now, as and when I get O, I will be shifting this 0 to 1, right. I have changed the parity here. Let us say I found another E, right? And at this point, I found another E, right? So I will be making this as 0 to 1. If I found another O, so I will be making this to 1 to 0. This 1 is becoming 0, right? Because this is even. What does this represent? What does this mask represent? This represents that all of the vowels are 0 except E. All of the vowels are even except E. Correct? All the vowels are even except E, because this is 1. Right? And this 1 represent the occurrence is odd. Right? So I am at here, and this represent all the vowels are even except T. See, as you can see, correct? If I move here K, so my mask would not be changing, because I have not represent the consonants. I have only represents the vowels. Correct. So this is my mask. If I move towards I, so I am making this as 1. I'm making this I is 1. So what does this represent? This represents that the occurrences of I and E are odd, except up to this string. Don't see this. Just see these 5 characters. So up to this string, the occurrences of I and E are odd. I hope you got my point. Now I'm scanning this another I, right? I'm just trying to visualize what kind of data structure you are going to use, what kind of thing that you are going to use. You can also make a map, right? You can also solve it using a map or prefix sum. Yeah, this is you can also use in prefix or XOR, right? But I want to discuss another very good technique called as bit masking, right? So this is nothing but a bit mask that I'm creating, right? So I am having another I, right? So I am changing this 1 to 0 again, right? So in this entire string, this is my final mask that I got. And what does this represent? This represents that in this string, right, my E is odd, right? So I have to eliminate this E. So this E cannot be my answer, right? So I have to take this substring. By the naked eye, you can see that if I eliminate this E, if I eliminate this substring, this prefix, the mask would be odd here. The mask of O would be becoming 1 here, right? So if I take OKII, so what would be my mask? So it would be like this. Correct. For O, it is 1. So I have to eliminate this O once again. So my answer would be KII. So if I take KII, what would be the value of mask? Value of mask is 0. Value of mask is 0. Right. So this is my integer, right? Let us represent it in terms of integer, right? So what is the value of, this is 8, right? This is 10, right? This is 2. This is also 2, right? And yeah, so this is 6, right? So we can represent in terms of an integer. The bit mask can be represented in terms of integer, right? Now why I have represented the bit position here, right? So see, you can see, definitely see this. I have represented A, E, I, O, U in powers of 2. In powers of 2. See, this is the power of 2, right? These are the bit positions. These are the bit positions, right? That can make up to this 5 numbers can make the integers in this range 0 to 31. 0 to 31. The value of t belongs to this range. Correct. Yep. So now I have I have found the occurrences. I have taken care of the occurrences. Should be, the mask should be 0. See, if my mask is 0, that means all the vowels are even. All vowels are even. Correct. So I want to make my mask as 0. So that would definitely give my answer. Now I would find the longest length. Right. I have to pick a substring which has a mask as 0. Right. So this is now my problem boils down to find a mask equal to 0, or you can say this mask can be, I taken this integer as t. So take this mask as t. So this mask is 0, which means that the vowels are even. Find a mask, right, which has longest length, right? So how I can find the longest length, right? I have found a mask which has 0, right? If I represented mask, I have represented all the substring in terms of mask. Correct. Now I have to find the longest length. So what we did in sliding window, can you recall? Can you recall? We maintained a map. We maintained a data structure which had the previous occurrences, which had a previous indexes. So what I'm trying to say is, at each and every just a second, at each and every mask, just put this, just maintain a map and put a mask and an index. Why map and mask and index? See, if I found, let us say this is my mask. Let's say this. See, initially I found this is my mask, right? At any stage I found another stage, I found the same mask, and my index is I. If I found the same mask again, so if I subtract both the indexes, I will be definitely getting my length. Correct? I will definitely getting my length. So in order to take care of the previous indexes, and in order to take care of the previous mask, that did they occur previously or not, I have to maintain a data structure. I have to maintain an array, or you can maintain any kind of data structure, right? If you can maintain an array from 0 to 31, right? 0 to 31, you can maintain this array as well. But I'm maintaining a map, or you can do anything, any storage you have to maintain, right? I am maintaining a map which has a mask and index. I have to check, does this mask existed previously? If they existed, I want to maximize my length by subtracting both the values. I have to subtract my I minus index. Right. So this is how I can get my longest length, right? I hope it is clear. I hope I am clear. So this is the only thing that you have to do, right? I have represented all my vowels as my mask, the occurrences as my mask. Now I have to find the occurrences, the previous occurrences. And if I subtract them, I would be and if I maximize them, I would be getting my this maximum length. Correct. Right. So now, what can I think of? Let us just dry run on this example. Let us what was it? OEOKII. Okay. So let us just dry run. What I'm trying to think is what we are trying to represent this. So now I'm maintaining a map. So I have to maintain a two data structures. Correct. I have to maintain a mask. I have to maintain a map. So this is what the thinking that you have to develop, right? You have for longest thing and for longest length, you have to maintain a map to subtract the previous occurrence and the current occurrence, right? So this is the previous occurrence and this is the current occurrence, and both are having the mask as same. So if you subtract this, you are definitely going to find your length, right? So Let us just dry run on this example. So this was our example, right? And let us say this is the initial state, the initial configuration, and let us say this is dollar here. This is -1 index. This is 0, 1, 2, 3, 4, 5. These are the indexes, right? Now I am also maintaining a map, or you can say, yeah, map. I'm maintaining, right? And now I initially I'm having mask as 0, and my index is -1, correct? So this is the configuration of my map. This is the configuration of my map initially, right? Now if I start parsing 0, right? Let us say I've got my 0, right? So what will be my mask? Please tell. Please think a minute, and what will be my mask? Let us say A, E, I, O, U. So what will be my mask? So see, I got 0, so I will make it as 1, right? So I have to check. Did this occurred in my map? I am having this in my map because I want longest length. So if it occurred in my map, I will just simply subtract and maximizing my answer, right? What I will be doing is, let us assume uh, I am having this mask in my map. So what will be my answer? My answer would be max of, say I'm maximizing my answer. So what we do in maximizing, right? We just subtract this current index. This is nothing but I means current index, right? So current index minus map of mask. Or this, let us say I represent it as t. So let us say this is my t. So this is my t, right? So this is my t. T is nothing but mask, right? So right, this is nothing but map, the value of t, right? So what is the value of t, right? So I don't have, if I find this in my map, but here I don't find. So what, I don't find this mask. So I will be inserting because let us say this mask occurred in future. This mask occurs in future. So for that I have to make an entry here, right? So I will be making an entry here. And what is the index? Index is 0, correct? So up to this O, what is my length? What is my length? My length is 0. My answer is 0 because I cannot pick O. This answer represent our final answer, the valid answer, right? So if I pick O, this cannot be my answer. So for this, let us say my string is O, just a single O. So this cannot be my answer because my vowels are odd, right? My mask is 1, right? Yeah, my mask is 1. See, so right, I am putting this into my map, right? Now let us say I am having E. So what will be my value of T? What will be my value of T? It would be 1 here. So this is my mask. This is my mask. So do I find it here? So you can clearly see there is no occurrences of this 10. This is nothing but 10, integer 10. So I will just simply insert 1010. And what is the index? Index is 1. Index is 1. Right. Index is 1. Index is 1. So now I again move towards O. Right. Now I will be flip this bit. I will be flipping this bit. How you can flip? Right. You learn XOR. XOR is an operation by using, you can flip a bit from 0 to 1 or from 1 to 0. You can do apply XOR, right? So this is not a bit manipulation concept that you do. By flipping, you have to apply XOR, right? So we will discuss that part in the code section, but just understand the algorithm first. If I get O, I will be changing this, right? See, occurrences of 0 is 1. So making it is 0. Right. So this is mine. So can I find this in my map? Can I find this in my map? So no, I didn't find it in my map. So I will be inserting this. What is the index? Index is 2. Right. My answer is 0 currently, right? Answer is 0 currently. Because if I pick any of this, I cannot see. If my string is O, my answer would be 0 because I cannot pick any substring. Because if I pick this, the value are odd. If I pick this, the value of E is odd, right? So I cannot pick up to this. I cannot pick any substring, right? So answer represent this. So currently my answer is 0. Currently my answer is, I will also be maintaining an answer. Answer is 0. Right? Answer is 0 currently. Right? Answer is not being updated. So if I find another, so see what I'm having K. So does K change my mask? No, because K is never going to change my mask because it is not a vowel, right? So see, now I will be getting I. So does I change my mask? Yes, it definitely changes my mask. I will be maintaining from 0 to 1. I'm flipping this bit, right? I'm doing nothing but just flipping this. I'm doing XOR, right? Or you can say just simply negate this bit, right? Correct, correct, correct. This is my mask. So do I find this? Do I find this? No, I didn't find this. So I simply insert in my map. Insert in my map. What is the value? The index is 4, correct? So here you can see one thing. Uh, Before this, when you had this mask, right? You had this mask 00010, right? So you did you find and this was not in your mask. So these two things were not in your mask, right? So at this time, at this point, you inserted this thing. You inserted this thing, right? And you had your substring as OEOK. That OEOK. So can you find a substring which contributes to your answer? No. So that's how you uh, consonant occurs, so that won't change your answer, right? So my at this point my answer was 0. So occurrence of k would also not change my answer, because if I either want a vowel, I either want O or E. I want O or E, right? In order to change my answer, right? Right, right, right. See, now I got my index as 4. Now for this index 5, right? So this is what will be the value of I. So it would change from 1 to 0, right? So do I find here? Do I find? Yes, I definitely find it. So what is the index? 2. And I definitely told you that subtract I minus map of mask or map of T. So what is it? What is the value of I? What is the value of I for the second I? It is 5. It is 5. 5 minus 2. So what is the value? 3. It is 3. It is 3. So if you take this entire substring, your answer is 3. As I told you, because if you pick KII, your answer is 3. So this is what you get if you are maximizing, right? So answer is max of 0. Initially it was 0, right? And max of 0, comma 5 minus 2. So answer is 0, comma 3. Max of 0, comma 3. What is the maximum of 0, comma 3? It is definitely 3. It's definitely 3. So I got my answer. I got my answer 3. I got my answer 3. Right? So yes, this algorithm works. And why I told you have to do this, because you have to make you have to make the entry of previous, right? Because I entered, I made this mask here. I made this mask here, and I also got this mask over here. Right? I got this mask over here. Correct, correct, correct. Because this bit was flipped. This bit was flipped, and this definitely had this mask here. Correct. See. So I guess this is the bit magic. This is the magic of the bits. You are flipping the bits. You are flipping the bits, and you are considering this substring. You are considering this substring. So I guess this algorithm works perfectly fine. You get, if you take this string, you get this answer as 3. Answer determines the substring where all the occurrences of vowels are even. So KII has even occurrences. So we got our answer as 3. We subtracted simply the occurrence of I is 5. So 5 minus 2 is 3. 5 minus 2 is 3. We maximize the answer, right? Correct, correct, correct. Now, you must have a question. Why we put -1 here? So this is a very, very important concept and very good observation that interviewer may ask you why you put -1 here? Why you put -1 here? So the answer is there is a catch here. So let us consider a string. Let us consider a string as KII. This is my string. So what will be the answer here? What will be the answer here? What will be the answer here? Let us say I'm having KII. Right. So what will be the answer here? So my answer would be 3 here. Right. Same. Answer would be 3. Answer would be 3. I just erase the map because the masks are going to be different here. Right. So let us say I'm not inserting anything. I'm not inserting anything. So initially I had inserted this thing. So if I don't insert this thing, let us say I'm having my map is empty currently, right? So what problems are you going to face, right? Because initially I too had not inserted this thing, right? Right. But then I debugged and I found that if your answer, right, this is my answer, KII itself is my answer. But if your first character is in the answer, then problem would be occurred, right? But in the previous case, O, E, O. So the first O is not going to be in your answer. So that didn't cause any problem. If you don't maintain this thing, that would not cause any problem because you are matching in the later part, right? Your mask match in the later part. But here, your mask have to match first thing. Your mask has to match in the first occurrence. That's the analogy that you have to create here, right? Let us say this is our string, and we are quickly doing dry run over here. So what will be the value of mask, right? So A, E, I, O, U, right? So this is our big representation. So let us say our mask is our map is empty, right? And what will be the value of mask here? So initially it is 0. So do I find this mask here? No, I don't find any here. I don't find here. So what is my answer? Initially my answer is 0. I don't find. So I will be putting this entry, I will be putting the value of mask in my map. So what is the index? Index is 0. Correct. This is what we do. This is what we did. Correct. Because I didn't find. I have to put my entry, right? And I won't update my answer. Initially my answer was 0, right? Now, this is my T or mask, you can say. Now if I find I, right? So what will be the value of mask? So it will be 1. So do I find here? Do I find here? No, I didn't find. So what is the value of index? What is the value of index? So index is 1, right? Now for the second I, what is the value of so this bit is flipped, this bit is flipped, right? So did you find here? Did you find here? Yes, you find here. You find here. So here, what is the value of I? I is 2. And what is the value of index? It is 0. And you have to maximize it with answer. So answer is 0. This is my answer initially. And you have to assign it to answer. So what is the answer? Answer is 2. I don't want that. I don't want that. So instead of inserting the first mask here, instead of inserting, what I can do, I can maintain a state as -1. Because this 0 caused me a problem, caused me a value lesser than 3, right? There is a difference of 1. So in order to make I inserted it previously. I inserted it previously and make it as -1. And I inserted it previously and make it as -1. Right. So at this point, let us say at this point, your mask is 0. At the first occurrence, at the K, you have mask as 0. You have mask as 0. Right? Did you find it in map? Yes, I found it in my map. I found it in my map. So what I'm going to do is I'm just maximizing my answer. What is my answer? Max of, this is nothing but max of 0, 0 minus and -1. Correct. This is I minus map of this mask. So this is nothing but 0, 1 max of. So what is my answer? At this point K, my answer is definitely 1. Because let us say you are having a single character. So you can pick this K. You can pick this K because it is a consonant. All the vowels are even. Right. For single character or in a cases where you are having your first character in your answer. So in this case, K I in is my answer, and first character is definitely going to contribute in my answer. So for that case, you have to match the first initial mask here. Like it should be present in your data structure. So that's how you can subtract, and that's how you can get your answer as 1. Right. So here my answer is updated to 1 here. My answer is updated to 1 here. It was 0, but I updated, right? I updated to 1, right? Now what is the value of I? What is the mask, right? So this is going to be my mask, right? Do I find it here? No, I don't find it here. I don't find it here, right? So what is the value of index? So index is 1. Index is 1. Correct. For now, I am flipping again for the second index. For the second I am flipping this bit again. So do I find it in my mask? Do I find it in my mask? Yes, I definitely find it in my mask. So what will be my answer? So index is 2 minus of -1. And what is my answer? Answer is 1. So I'm maximizing my answer. So my answer is max of 1, 3. So my answer is 3. So I got my answer as 3. But if I didn't put this initial state in my answer, I definitely got my answer as 2, right? So there is a edge case. That if you are having your first character in your answer, that contributes to the answer, so that means you have to put this thing, because I know that first character is contributing to my answer. You have to decrement the value, right? Because you are subtracting the previous value, because you are at the dollar, right? You are at the dollar and you want the initial state. So what you are at the dollar, what was the initial state? Mask was 0. right? The index was -1, so you have to take care of that. You have to take care of the previous value, right? So what is the previous value of 0? 0 is my index, right? So what is the previous value? Previous is a -1 index. Correct, correct, correct. Each and every step you are taking care of the previous index, previous occurrences, correct? So for that case, for first character in answer that contributes, I have to put this mask. I have to put this mask, right? For this case. But if your first character does not contribute in the answer, you cannot put, right? I mean, that won't make much difference, right? So that's all from my side, and let me just quickly discuss the code, right? How you will implement. So implementation is maybe hard for few folks, that how you have to calculate, how you to flip this bits, right? So for flipping, what you can do is you can simply put XOR with a flip, or yeah. So let me just discuss how you can XOR, right, or how you can do such kind of manipulations, right? So that's a very tricky part. Yeah, even I was thinking that how you can do it in very cleaner way, right? So let me just discuss the code. So this is the code, right? So initially what I'm trying to do is, this is nothing but the flip. So this is nothing but the flip bit. So I'm just flipping. So this is nothing but a temp variable, you can say. This is my answer is initialized to 0. My mask is initially 0. As I told you, my mask was 0, right? This is my end size of the string, and yeah, see, this is very much important. This is very much important. As I discussed you, this is the edge case that you take care of. Right, this map represents the map that we discussed, right? Now, if it is your vowel, if it is vowel is true, then only you have to change your mask, right? But if, let us say I'm having K, so you don't need to change your mask, right? Because my mask is made up of vowels, right? Correctly. So let us say I'm not having any vowel, right? For an instance, right? So I'm checking that map.count means, does this flip, or does this mask exist in my map? Yes. So if it exists, I'm just doing this operation that I explained you. I'm maximizing my answer. If it is exist, and if it does not exist, I'm just putting my mask in at a particular index. Correctly? Correct. 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 Now let me just discuss how you can calculate the mask, how you can flip the bits, right? So let us say this is, as I told you, this is my vowel map. So what vowel map represents? So I just, as I told you, this is A, E, I, O, U. So what is the value of at A? A is 1, right? E is 1 0, right? So 1 0 is nothing but 2, right? So this is 2 here, right? I is 1 0 0. So what is 1 0 0? So it is 4. That is the power of 2 that I discussed, right? O is nothing but 1 0 0, right? U is nothing but, this is U, right? So this is 16, right? So this is the thing but vowel map. So you have to flip, or you can just simply do another hack that I thought, that S of I, this is my string, and you have to left shift by 1. So in minus A, right? Definitely, yeah. So this is how you can also do this, right? So this is how you will get the same value, right? Yeah. So let us say I'm having A minus A. So it is 0, right? So you have to flipping that. So you are flipping just 0 bit. So it is initially 1, right? Correct, correct. Right, so same goes for all these things. Right, so I've got my mask here. So see, this is my mask, right? This is my mask. And what I'm doing is I'm flipping it, XORing with 0. See, let me just tell you one thing. This is my flip. Initially, this is my flip. Right, and this is my mask. What is my mask? I got my mask as, let us say this is my string as or O E O K I I. This is my string, right? So for this O, what will be my mask? A T I O U. So what is the value of O? 8. So this would be my mask. Now I'm XORing. So what for XOR, the XORing with 0. So it would be giving me this thing only, right? So my flip is here. My flip is here. Now for E, I want to XOR this bit. Why I'm XORing? Well, let us say I got another one. So 1 XOR 1 is 0. So I'm flipping this front to 0. I'm flipping this 1 to 0 if I'm XORing with the previous flip, right? So for that, I'm doing XOR. As I told you, for flipping, you have to use XOR with the previous value, previous mask, right? So this flip has the previous mask, right? You can say like that, right? Now, if you're, what is the value of E, right? So E is, let us say 2. So it would be here, right? If you're XORing this with this, XORing these two values, this and this, what will you get? What will you get? So you will get 0 0 1 0. Okay. So Yeah, so this is 0. Okay, so this should be 0. Yeah, so this is the mask of E, right? This is the mask of E, right? So you will get 1. So this is my new mask. This is my new mask, right? As we discussed in a dry run. So I have to check in my map. So is this 1010 present? Is this 1010 present? As we discussed here. Can you just erase this? But yeah, so I hope you got the point. Why I'm XORing? So let us say this is my bit position, and if I'm XORing the same thing, this would be 0. Right. Or let us say I'm having this. So I am changing this bit. I am changing this bit. Right. Let us say E occurred. Or let us say A occurred. A. Right. So what is the value of mask? What is the value of mask for the first A? This is first A, right? So this is my mask, and I'm XORing with flip. This is my flip. I'm XORed. So what is the value of new mask? So this is flip is nothing but a new mask, you can say, right? So the value of flip is this now, right? Value of flip is this. Now I'm XORing with another mask of A. What is the mask of A? This is the mask of A, right? Now if I XOR this both the terms, what will be the value? It will be 0. It will be 0, and this represents the occurrence of A is E1. Occurrence of A is E1. Right. Occurrence of A is E1. This is nothing but flip equal to flip XOR mask. Correct. And how I calculated this mask? From the vowel map. The power of 2. Correct. Or you can do this, or you can do another hack that I can think of. As I using what you can say, the left shift operator, right? So if you XOR it with this S of I minus A, this is also going to work. Correct. Now assign it to flip. If you don't do this, if you don't have any mask, or you can for cleaner code just do this thing, right? But yeah, you can also, this thing also works. You can simply dry run. Okay, so that's all from my side. I mean, this is very good concept using bit masking. You can, and yeah, you can add this to your toolkit, right? Because let us say I heard a quote, right? If you see a problem once, right? If you see a problem once, so it is a technique, or let us say it is a what you can say, it is a new algorithm, you can say. If you see a problem once, but if you see a problem twice, then it is a technique. If you see a problem once, it is a, or what you can say, it is a simple logic, or you can say ad hoc kind of problem, right? But if you see a problem twice, it is a technique, and you have to add this technique in your toolkit. So yeah, that's all from my side, and I hope you learned something new. Yeah. Also one thing that I want to discuss. You can also solve this problem using a prefix XOR. You can find this thing, prefix XOR technique. Right. So what do you want to do here? Right. So same thing that you have to represent all the vowels. Let us say A, E. I'm just discussing the approach. I, O, U. Right. And this is your homework that you have to. You can try this technique. I'm just explaining the approach. Right. Now you have to represent all the numbers in a prefix array. Right. So let us say from index number I, what is the XOR? What is the XOR up to of this mask? Right. Again, I have this mask. Let us say I'm having A. Right. So you have to XOR with the previous mask. Right. So let us say, and you have to XOR with the previous mask, as we did in yesterday's problem. You have to XOR it with the previous mask, and you have to check the continuous values. So if I get the continuous occurrence of 0, right, if I get the continuous occurrences of 0, that would be my answer in the prefix array, right. Because if you XOR it with XOR the same number, if you XOR the A twice, A XOR A, you would get 0, right. So if you get the same number, or let us say you get 8, or it's the same continuous values, so that would contribute to your answer. So I guess this is a technique that you can explore. I'm not sure about the implementation, but yeah, you can definitely see this. So thank you very much, guys, and thanks for listening. And I hope, if you didn't understand the approach, if you didn't understand the working of this problem, simply just watch the previous previous 5 to 10 minutes, you will definitely get what I'm trying to say and why I represented this vowels in terms of bits and because I want to toggle from odd to even, right? So that's how the intuition comes, right, of bit masking, right? So that's how you can solve this problem. So thank you very much, guys.